All right, so what we want to do now is we want to calculate the total height of CE for this figure at the moment. And let's just highlight this here. So the question says calculate the height of CE. Now remember, CE is this whole line over here. That's what we want to calculate the height of. Now CE is made up of two parts. They've even broken up the parts for us. They've taken the first part, CD, which is part of this triangle over here. And you can see we're given an angle and a side. And then at the bottom, we've got to find that side, which is part of this trapezium. Right, now we can use trigonometry and we can use geometry to solve this question. We're going to probably find it in parts, right? So we can find this part first and this part second, and then add it up. And then we got the total, but we have to look at it in each component separately. So the question says calculate the total height of CE for the figure on the right. Let's jump into this one. Okay. All right, so the first thing here is what we must remember is that some problems require you to do several trigonometric calculations. So it's best to do your calculations all together and then round your answer only at the end. So you avoid rounding errors. Sometimes this is difficult, in which case we round the intermediate answers, or at least one more significant figure than required in the answer. All right. So depending on what's required, we're going to round it to 2 decimal places at the end. Let's have a look at each of the separate calculations. The first one I'm going to calculate over here is CD from this triangle here. And I can see that CD is going to be my opposite side. Because remember, if I'm standing here, that side becomes my opposite side. And my longest side is my hypotenuse. And remember, if I've got saw, car, and toa, it will help me to choose whether I use sine, cos, or tan quickly. The first letter O and H relate to O and H over here. And so I can see I have to use sine because there's no O and H in any of the other two. And this is sine, cos, and tan, S, C, and T. So from this here, I'm going to find CD. And I'm going to say, well, CD, call it CD as my opposite side. And whenever I start a question like this, remember that I've got to write down an equation. Okay, so I've got to write down some kind of equation. So I'm going to go sine of the angle equals opposite over the hypotenuse, which is going to be 5.7. And because the unknown is at the top, I end up taking 5.7 over and I multiply it on the left-hand side. So I get 5.7 times sine 53 degrees. That's going to become CD. I put that on a calculator. 5.7 sine 53 comes to 4.55 meters. And that's 2 decimal places, right? 2 decimal places done. So I know I put it in my diagram. I got 4.55 now. So that's cool. That's all done there. Now that I have that, I'm halfway there. I mean, I've just got to find DE, and I'm sorted. I found the height, which is the question. So to find the next part, which is DE, I've got to look at the next shape. Now, DE, if we look at it, we also have these two parallel lines. Before we go there, this 2 parallel lines, it means we can get some angles involved in here. This is 90 degrees. This is 90 degrees here as well. I can see this is 23 degrees. What if I broke this up into different parts, right? I can also, if these two are parallel, obviously if I draw a line down here, then the length of this side, here, DE, and that would be exactly the same. All right, so DE and whatever that is would be exactly the same. This is your diagram. This is your space. You can name it. I mean, we've got A, B, C, D, E. Let's go to the next letter. Let's put F here. Okay, so I put F here, and I look at this triangle. This is a right angle triangle. And that's what we're dealing with, right angle triangles. And look at this. I have an angle. I have the hypotenuse. And again, I want to find the opposite side. I'm going to do exactly the same thing and just change the values. I'm going to call this one BF. All right. So to find BF, the CD is done. To find BF now, I'm going to say sine again. 23 is equal to BF opposite of our hypotenuse, which is 6.1. going to move the 6.1 across, multiply it, 6.1 times sine 23, that becomes BF. And so BF will equal 2.38 on a calculator, meters, 2 decimal places. Okay. Now I can just simply add it up and I'm done because I just found this one here, be 2.38 meters. So take that and we add it up. And so therefore we write CE is equal to 4.55 plus 2.38. That comes to 6.94 meters to 2 decimal places. And that's it. And now we found the length of CE, right? We took CD plus DE. How did we do this? We looked at each part separately, and I had to create this triangle from nothing. It wasn't there. I had to put the dotted line in so that I could visualize another triangle and then use sine. In this case, I use sine. I could have possibly used cos next time or tan. I may have to rearrange the equation to divide depending on the requirements. So however that plays out, I've got to be flexible about it.